Okay, ladies and gentlemen, welcome to our final lecture for the week of EECS 404 Game Engine Architecture. I just ordered your stickers, your course completion stickers, and it struck me once again, this is the final semester in which the course will be known as EECS 498. It is becoming EECS 404 next semester, and well, we'll see how it goes. We'll see if anyone can find it in the course guide, being so down low in the early 400s. We'll see. We'll see. If you look at where we are right now on the schedule, you see this, we're in the middle of homework 8, yes, but you know what catches my eye? Do you see this big red block down here? It's kind of scary. What could it be?
Exam.
Oh, no. Oh, no. It is your exam, okay? And the truly scary part about this exam is that okay, now I'm distracted watching Gavin play the 494 game. Okay, hold on one second. All right. Okay, major update to all the May and Magna games at the top of the website. I added my first bot, my first server-controlled bot, which is just this dog. His name is Rover. His mission is to rove around on the top of the screen and try and convince you to play the game. The motion is really helpful. And also, it's meant to hint to you that it might be multiplayer. So maybe you should send it to your friend. This is all a ploy to make the websites go a little bit more viral, which is a ploy to boost my enrollment numbers, which is a ploy to take over game dev at University of Michigan, which is a ploy to take over the University of Michigan, okay? Anyway, its ploy is all the way down, all right? It's a whole master plan. We'll have to see how it goes. Anyway, okay, so what was I talking about again? Oh, yeah. So the really scary thing about this exam coming up is that I have to finish the design of the exam, and I'm only about halfway finished. Because here's the thing. We're about to talk about Twine for our game engine of the day, a really cool engine. But there are only so many game engines of the day in this course, and each engine only has so many interesting things to make a question out of. And so every single semester becomes harder and harder to make an exam that's not recycling questions from the publicly posted previous exams. Eventually, I will have to change the course contents, or I will have to start recycling questions from previous exams. And that's something I really don't want to do. I expect as soon as I start doing that, I have to either make the questions much harder, like unfairly hard, which I don't want to do, or I have to start, we're going to see a big score boost on the final exam in the average grade, because people will just do the practice exams and they will see the same questions on the final. And if the exam grades go up too much, then I have to make other parts of the course harder to target the required B average grade that I'm required to have. Does that mean I have to make the projects even harder? Ooh, I don't want to do that. So I'm in a jam. All right, well, that's my problem, not yours. That's why I get paid the medium bucks to make these courses and make them okay. All right. Anyway, all right. So. Please, the important thing here is please know that we're in the middle of homework 8. I'm telling you, it's not the end of the world if you haven't reached homework 8. But folks, I see a lot of students who are dumping time into inefficient parts of the course, okay? Please do not burn a bunch of time trying to finish the performance integration test cases of homework 6, okay? It's not that important. You're going to rip out a lot of that gameplay code in homework 7 anyway, and for the amount of time and effort you're going to put into those integration homework 6 test cases at the very end, you're not getting much points out of that. Okay, you're not getting many points. It's fun, it's interesting, I know. Come back later if you have time. Hey, you're using Git. You can go back in time. It's easy, you won't lose anything. You can go back in time when you have time. You can even submit after the autograder off date, okay? Which is Monday, April 6th. It's the Monday after the exam, so you have the weekend to try and finish things up. Okay, but after the autograder off date, you can keep submitting if you want to. You just won't earn any points for any submission after that date. On Discord, someone asked about like, oh, can I resubmit? What happens if I get a lower score? The autograder will never lower your Canvas score, okay? The highest grade you ever get on an assignment, you're getting that grade. Okay, you don't have to worry about a rogue submission taking your score back down to 0. Okay, this is a friendly autograder, and I mean that. And the reason it is friendly is because the amount of stuff you need to get through in this course is hardcore. This is a hardcore course, and if our autograder had the design philosophy of the EECS 281 autograder with its limited submissions, the course would be impossible. Okay, we would have to dramatically pare back what we ask of you, and so we don't want to do that, right? So anyway, keep that in mind. You only have what? Let's see here, 1, 2, less than 3 weeks. You have less than 3 weeks remaining until that autograder off date, and so you need to be moving, and you need to be making very prudent, cold, calculating choices. If you're behind on these homeworks, you need to be slicing and dicing and cutting and deciding what you're not going to do. All right? You need to be sacrificing in order to scoop up as many of these points as you can. It'd be really nice if you could get a lot of these homework 8 points without that late penalty, and then homework 9 is a big bundle of points, easy to get. And you don't want to get that 20% penalty on those either. Okay? All right. Any questions or comments? Okay. We just had someone beat homework 8 100% last night. Congratulations. You know who you are. Good job. Well done. This is a hard course. Don't forget that. Okay. We have Twine as our game engine of the day. Most of today is going to be talking about Box2D and the Box2D physics engine, kind of why it works the way it does, and its internal model. We're also going to talk a little bit about PubSub, because you do need to set up a very basic and kind of simple event-driven system. And I want you to understand why event-based programming, event-driven programming, is common in games and why it's so nice for keeping your code base clean and decoupled. We're also going to review quiz number 4, because there were some pretty nasty problems on there. I think really good problems, but pretty formidable problems. And the thing that's really important to know about the way you can really give yourself an advantage on these quizzes and on the exam and on a lot of tests if you understand why tests are designed the way they are. And I'll explain that in just a little bit, okay? Okay, so I want to talk about Twine. This is a very famous game engine. It's also a very particular game engine. It is meant for kind of text games, dialogue-based games, choose-your-own-adventure novel-style games that are interactive but very textual, and usually they are geared toward not real-time gameplay, though they can have that, but toward choose-your-own-adventure style, book-style games, okay? It was created in 2009 by Chris Klimas, who has this website right here, and I think this website has some reflections on Twine and some other cool stuff that he's done. He dev blogs on here. Seems like a cool person. It is famous for smaller scale games like You Are Jeff Bezos, a billionaire simulator. It is also famous for the game Depression Quest, which I'm not super excited to say anything more about that game. It's it's very much a part of the famous or infamous kind of Gamergate scandal and harassment that occurred some time ago, which the industry in many ways hasn't quite moved on from or recovered from. It's a very divisive topic, and I'm not prepared to cover it. So that's all I'm going to say on that topic. But you can look more into it if you want to. It is an engine for creating hypertext stories, which means stories or dialogue or novels that can be enriched with multimedia, audio, branching dialogue, imagery, videos. It is web-based. It uses web technology, which means you can actually use the HTML5 canvas. and JavaScript. And you can literally build that game I was just showing you. This could be part of a Twine game, okay, if you wanted it to be. Now, every time I see the dog, I get excited because I think there's a player and I can jump around with them. And then I realize it's a fake, okay? Sad, sad. So it was created in response to constraints of existing software around the time. Its inspiration was the kind of growing power and universality of the browser and how nice it was to be able to play a game on any device, no matter if you were Mac or PC, if you were on a desktop or laptop or even a mobile device. The primary engine it is the primary game engine of UARTS 150, which is a course that's called Introduction to the Creative Process. And we chose the engine in that course when I was teaching it because that course was very unique. It was first semester freshmen in that course. And that brings its own host of problems, okay? A lot of high school drama gets dragged into that course because of the unique early audience of it. But it was also the residential living arts college, which is a diverse group, a very heterogeneous group of artists and musicians and drama students and some engineers and some writing students. It was just crazy. And it was really hard to make a course designed around that very diverse group. But the Twine engine was easy enough for everyone to use, even the writing students, and it had enough power that even the engineering students were kind of okay with it. The development interface looks like this, okay? And I'm going to show this to you right now. It basically is this kind of board where you create these little sticky notes. These are called passages, and these passages are basically blocks of text, blocks of content. They can have images in them, they can have games in them, whatever you want. But what's really important is that they can also have multiple choice selections. And these selections down here allow you to branch to different passages. So find a chair and sit home is an option you will see. Bail and walk home is an option you will see. And you can then traverse to these other passages you see down here. As you build your game in this engine, it creates this big graph of passages. And they can be cyclic if you want to. You can go in a loop if you want to. You can create variables. You can display the value of those variables, as you're going to see in a bit when we play You Are Jeff Bezos. And you can do all sorts of stuff with those variables. You can change the text that you show. You can have like a little HP UI bar by showing the right variables at the right time. You can double click on these passages and you get this nice editor for editing the contents of those passages. You can click this button that says test from here, and you'll go into the browser and you'll actually run the game, right? On a dark and stormy night, you arrive at the Viz Studio for EECS 498 Game Engine Architecture. Rumors say the game engine today will be Twine. Should you find a chair and sit down, or should you bail and walk home? Well, I'm going to click one of these. I'm going to go to, let me see, find a chair and walk home. It says, the lecture passes quickly. Twine, it turns out, is very cool. Blah, 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 the end, okay? You get a bunch of features with Twine by default. You can go backward in Twine. You can, I think you can also have like a voice readout and narrate the game to you if you want for accessibility stuff. It's kind of cool. But yeah, so you can use Twine. In fact, you can use the Twine editor in your browser. So you can create a new story, right? Hello world. And we can double click to create a passage. We can title the passage, start. Oh, I guess I can. How do I title? Oh, rename the passage. Here we go. Okay. You walk into the Duderstadt late at night. To your horror, you see a big, giant poster for EECS 298 next semester. Do you take it The course, I mean. Okay, hold on. Ignore Austin's advice and skip the course. What do we do? So when I finish writing these and close the passage, you'll see we have a few more passages here. I can look around. We can create a really, really big story if we want to. I think we can even zoom in and zoom out. Now, if you take the course, you end up having a swell career because your stuff look good. The end. Sweet. But if you ignore my advice, your games look not so good. You end up teaching like Austin. Bad ending. Oh. It's not that bad of an ending. Okay. And then I can play my game. I can actually compile this game if I want to. I think I can go to build and I can export it as a website. I can then host it wherever I want. I can host it on itch.io. I can host it on my own server, my own website, whatever I want to do. It's just a bunch of web files, right? And so I choose to take the course. And so I end up having a swell career, but I can go backward and I can ignore my advice if I want to, and I get the bad ending. We can set up variables. We can do all sorts of stuff. It's really pretty fun. And if you are a writer and you're not super good with technology, let alone programming, then this is possibly a really great way for you to start making your own interactive stories, start creating characters. The stuff you really want to do, you can get to it fast, and the interface is great. It's like a souped-up Microsoft Word. Okay, so it's very familiar to you if you have been doing some writing. Twine, it is possible to embed Twine into Unity using plugins like Cradle. And there are teams like Nochi in Ann Arbor that I think they make their games mostly in Twine, and they bring it into Unity via these plugins. Why do they do this? Well, they do it in part because Unity is really good at exporting to consoles and different web systems in a way that Twine can't quite do. So you can do all sorts of cool stuff. It's a great dialogue system if you want it to be that. Let's go ahead and play You Are Jeff Bezos. When you wake up this morning from unsettling dreams, you find yourself changed in your bed into a monstrous vermin. You are Jeff Bezos. And we have 156 billion dollars. Okay? Now that's our net worth. We wouldn't actually be able to cash that right away unless we got like a loan or something. But okay, his employees are now our employees. His money's now mine. Okay? What do I do? What do I do? Should I go to the bathroom? Should I scream and sob? Should I spend all his fucking money?
Spend his money.
Spend his money. Let's go. Okay. I have decided I can't afford to pay off student loan debt for everyone. I don't know if I'd want to do that. Sorry, everyone. You got to pay your loans, okay? Anyway, should we repair Puerto Rico? Should we pay for the border wall and then not build it? Where's this money go? Pay personal taxes. Should I hire 100,000 new teachers for 4 years each? The layoff wave that's going to happen after that 4-year contract is up is going to be like a disaster, a gigantic disaster. Should I end homelessness in the USA? What should I do? What do you want? End the homelessness. Okay, we're going to create a bunch of really nice care centers that will help get people back on their feet. You eliminate homelessness in the USA. Every person in the USA now has the guarantee of a roof over their head. That's pretty cool. It's not clear how we beat the NIMBY laws. But that's okay. Don't worry about that. This costs you $20 billion, 12.8 of your starting net worth. You still have this much. I'll soon change that. Okay, we have lost the ability to repair Puerto Rico, and we've lost the ability to end homelessness. Do we have other options? We've got other options. That's pretty fun. Anyway, so you can see that there's interactivity here. Now, I actually saw on itch.io, there are a lot of games. There's an entire Twine category that you can check out. I really like this one. Your phone dies in 20 seconds. You want to play it? This is not going to be very long. Are you ready? This is really cool. I like it a lot. Your phone dies in 20 seconds. Start. You have finished a late night shift at 12 a.m. The streets of the small town have encompassed in darkness. The buses have terminated. You have no choice but walk home, which is 25 minutes away. You hear the sounds of footsteps behind you. You have a strong feeling in your gut that you're being followed. Hands shaking, you pull out your phone. You only have 5% battery on your left on your phone. You haven't got much time. What are you going to do? And I'm recording, right? Yeah, we are. Should I turn on my phone? Should I risk it and walk faster? We got to turn on the phone, right? Yeah, let's do it. Turn on the phone. Okay, 19, 18. Am I going to contact? I got to contact my boy Luke. Okay, you have 2 years lives with you in your home. Okay, hey, you awake? Yeah, what's up? I'm asking for a favor. I'm walking down the street. I think I'm being followed. Really? Is this a prank? One of those stupid relationship things? I'm not kidding. It's serious. Okay, where are you at then? Wolves Drive. That's pretty far from me. No, it's not. I'm in. Oh, your phone is now dead. You are left alone in the dark streets, okay? You take a deep breath and walk a bit faster. You can only pray you will make it home. 6 hours later, woman reported missing. Oh, bad ending, okay? Very sad, blah, 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 blah. If you have information on her disappearance, please, I love how this changes perspective from the player character to the people who are reporting her disappearance. That's pretty creepy, okay? Interactivity, real-time gameplay. Pretty awesome, right? Pretty sweet. So anyway, if you want to experiment with a storyline, if you can make an engaging story in this format, maybe it will be super engaging if you put it into a real-time game. I don't know. But the appeal, I think, is really clear. And I'm really happy this is an open source engine that exists and is so nice and user-friendly, and you can just kind of pull it off the shelf. Really quickly, as I see people looking at the AutoGrader dashboard, is everything still alive? Sweet. Okay, good. That makes me happy. All right. I did swap out the 7C3 test case, but I made it much shorter, and that's an effort to try and speed up the grading, which people were complaining about. Okay. Blah, 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 blah. All right. So some reminders as the end of the semester draws near. AutoGrader off date is approaching pretty rapidly. You will have the weekend following the exam, but you won't have any more than that. And a weekend is not a ton of time to catch up, okay? So be careful. Be careful, especially as office hours are limited at that point. You will still have Sunday office hours, and you will have Max's office hours, but be careful. Don't lose hope if your grading is a bit rough, okay? If your grade's looking a bit not so good, if it's down in the dumps right now, remember, we haven't graded the extra credit yet. The final exam usually balanced to be a little bit more gentle, even than some of the quizzes. And there are a lot of points left still on the board, okay? Those last few assignments in the course, pretty easy to get all those points. That's really going to help you out, okay? So don't panic. Don't lose hope. Things look worse than they probably currently are, but do put in a real deal, very tough effort to try and get as many of these homework points as you can before the exam arrives and the AutoGrader air quotes shuts off, okay? Homework 9 is a short homework assignment. I might make it a little bit longer because it was very short last semester. It's going to be short again. They called it a victory lap last semester, and I take offense to that. Okay, it's not meant to be a victory lap. It has educational outcomes that I want you to enjoy and earn. But it's probably never going to be very difficult, okay? Okay, let's talk a little bit about homework quiz number 4. Okay, so here's a question that I got people. This relates to inheritance. Setting up inheritance in Lua is very important for your architecture and your code base. And this is something we gave you some of the code to do in C++, but we do want you to understand the small amount of what's happening here, okay? And what we have here is we have a character class, well, a character table, and we've provided a bunch of constructor-like functions, and we want you to tell us which one is setting up inheritance properly, i.e., which one is actually a bona fide constructor for this table, okay, this air quotes class. And so we have a new one function, which is just returning the character table, which is not going to help you. If you return the character table and then you start editing it, you are editing the core like class type table. As in, you are bulldozing any other table that might be using it. and inheriting from it. Don't do that, okay? Very bad. New2 is a funny one. It's literally just giving you a table, if you call it. Like, this could be any function. It could be anywhere. It doesn't need to be inside the character table. It gets nothing from being inside the character table. It's just a function we just kind of put in there. But, it doesn't do anything. For new3, we are creating a new table, and then we're returning that table. It's the same thing as new2, just expressed in 2 lines instead of, 1. New4 is a little bit more interesting. It is trying, but failing, to set up inheritance. It creates a new table here. It then sets a meta table for this table, okay? And it's saying the meta table is character, i.e., the parent table. The problem, though, is that this is not how meta tables work. The character table is not a useful meta table, and so we should not be creating a new instance, a new table, and then telling it that its meta table is the character table. Why is the character table not a very useful meta table? It's because it's not using any of the special meta table members, the properties, okay? Like __index, which is truly the secret sauce that makes inheritance work, okay? So we're getting closer, but this is still not correct, all right? So we move on to new 5. This one will create a new instance, a new table. That's a good start. It then tells that new table that it has a meta table. The meta table that it has is this table right here, which is a genuine meta table. Why? Because it has that famous __index member inside of it. That makes it a useful meta table. Here, the character table is becoming the meta table for this table, this new table, but because it doesn't have any useful members like index, it isn't a useful meta table. This table is really small, but it has a useful member in it. The index variable, the index member, if you have it, is going to tell the Lua interpreter which parent table should I look at if the child table lacks something, okay? And that kind of is what inheritance is if you think about it. So new 5 is the answer, and this right here, this ain't a thing, okay? I don't think this will compile, this code, because this is not a thing. I have no idea what this colon even is, okay? It's trying to confuse you with the syntax from other languages. Okay, anyway, so the answer is, there you go, new 5, okay. Anyone have any questions on that last one? Okay. Again, the syntax is weird. If you use it in making some games, you're going to get used to it, and then it's easy. It's permanently in your memory, and you'll rock this on the exam. It's just no big deal. That's why I say that, like, making a game with your engine is one of the most valuable ways you can study this stuff. Okay? Not only will you memorize certain things, but you'll start to understand what's actually happening, which is what the exam is going to try and check. Okay, your friend is programming a video game using their course engine and shows you their gameplay code. This is fine as you're not being showed blah, blah, blah. Okay, your friend is charming but prone to writing errors and subtle bugs. This is my way of telling you they wrote a bug here and we want you to find it. What do we see every frame when the above component is attached to an active actor? Assume the if statement on line number 9 succeeds. So basically, every question that I design, I don't know if I assume other exam designers, other professors do it this way as well, or at least try to. Every question that I make starts from a question of, there's some topic I want my students to know about or understand. How do I create a question that explores that topic? This topic is about a Lua foot gun, and most of the questions on this quiz are going to be about Lua foot guns, okay? Well, most of the big, hard questions are going to be about the Lua foot guns that we explicitly talked about during our lectures, okay, over the past several weeks. This one, I'll give you a hint, it's about the missing self reference. It's about the weird way in which Lua creates global variables by default instead of local ones, okay? In Lua, if you want to refer to one of the variables inside of your table, you must remember to use the self keyword. Otherwise, you are referencing and creating or reading a global variable, which may or may not even exist, okay? So, what's the answer here? We're going to run on start, we're going to run this if statement. We are told that it succeeds, and so energy equals 0. Energy is a member variable that exists within this table, but it's not the variable that we are writing here, because this is not self.energy, this is energy, which means it's a global. It's a different variable entirely from self.energy. Within update, we're going to print every single frame self.energy, which is still 100, even after this if statement succeeds. And that's one of the foot guns of Lua. Okay, so the answer is 100. All right, questions about that? Anyone? All right. Here is another foot gun, okay? You are asked to debug a Lua component that's throwing an error. The particular error is attempts to index a global self value, a nil value. Which of the lines below is the culprit? So a good test-taking tool here is to just look at the lines that are available to you as an answer. We can look at line 3. Let's go up to line 3. Yeah, HP equals 100. This is just a standard member creation, a default value for a member. You can think of it like a declaration, but it doesn't need, it's not really a declaration. It kind of looks like one though, so I like to define it up there. How about line 12? Line 12 is up here. It's in the onStart function. It says debug.log. We have some text, we have some concatenation. Self.name, is that a thing that exists? It is, okay? It absolutely is. It might print question mark, question mark, question mark, which is maybe going to tell us that, you know, we should initialize that and not leave it like that, but it's fine. It's not going to cause an error. It might cause a design bug, but, you know. Okay, we can go to 16. Line 16 is right here. In the onUpdate function, we have a little self reference here, and it's going to run every single frame. Line 16, self, we have colon, progress stats. If you look at the progress stats function, it is actually defined, and it takes a self-reference. So this colon is the correct thing to use to call it properly. Self is then used as you would expect, and the function ends. So line 16 is totally fine. Line 18 ends up being the answer, and the reason is the self-reference. This is a question about dot versus colon when it comes to calling functions. What is the difference between them and what do they mean? Which one should you use? If you understand what the difference is, then you might hopefully notice that this is using dot instead of colon. If you go and find the progress function, here it is, and it has a self-reference, and that's a big deal, okay? If this didn't have a self-reference here, then this would be perfectly fine. But what's going to happen is that line 18 is going to end up causing a chain of issues here. We're going to go into progress battle, and the self-reference is going to be nil. The self-reference is nil, which means on line 30, it is going to fail hardcore. Actually, no, it's going to fail on line 29. You'll notice that line 29 would be a decent answer here. But I specifically excluded line 29 so that you wouldn't get confused, all right, and accidentally pick it. And so there you go, all right? Line 18 is the much better answer, as it kind of causes this problem to occur in the first place. You can look up the other several answers if you want to. I want to save some time. Here's a big one. It kind of forces you to look across multiple files. You've got the scene file here where we have an actor called myActor. It has one component. The component type is called chatty component. We can see down here that, yes, this is a valid type. It has one override for a variable called magic number that is 48. And so you come across this blah, 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 a buggy component. So you know something is wrong with the component. We got to figure out what it is. And we are asked what will output on the very first frame of the game. So let's look at the component. Hello. Okay. So chatty component, it has magic number, it has a bunch of other stuff. It all compiles, so we don't need to worry about that. In onStart is a valid function. It's going to run on the first frame. We print onStart message, but again, this is also testing you on whether you notice the self-reference or not. Okay? OnStart message is a defined, with a default value, member variable of this table. But we are not checking self.onStartMessage. We're checking the global value onStartMessage, which does not exist. Okay? It does not exist. And so we're going to print nil. All right? So that's like, that eliminates a bunch of our options here. We've eliminated the first two. Now it's the final three options we have to consider. On update, despite being below on late update, on update will be the next function to run in our engine. If you've completed homework 7, you know that. You know that's the value of on late update. On late update is guaranteed to run after all of the other on updates for all the components, for all the actors, has run. So on update will run next, and as you can see, it's printing out self.onLateUpdate, which is hello from late update. So we expect hello from late update to run next, and is that an option for us? Nil, hello from late update, and so we can actually stop answering the question right there. We do also then run late update. On late update, we check the magic number. It's not going to be smaller than 10. It's going to be larger than 10, right? So we'll run very magical. We'll say that. And there we go. There's the answer. This is kind of deliberately obtuse. The code here is really poorly written. Here's a final one, and this one relates to the one indexing nature of Lua. It's another one of those foot guns that Lua has that we want you to know about. And here, if you know about it, then there's a good chance you will solve it correctly. All right. You write a program that will tell all of your friends which courses to take next semester, and I should really put 404 in here, and then I should figure out what my game engine MMO course, what the number might be, and I should put that in here to start advertising for it, okay? Okay, here's the thing about marketing and advertising. Have any of you played World of Warcraft? Have you played an RPG game, an MMO? Okay, it's all about the buffs, right? It's all about the buffs, baby. And so, what is a buff, right? A passive buff. It is this little tiny bonus you can add to your character, and they stack and have a big difference over time. It's like investing. At first, 7% per year in returns feels like nothing, but that compounds, and it really starts to become a big deal over time. And so I like to sneak references to my courses in every other course. By the way, for those of you who weren't here earlier, I need to get my clicker out. This on the wall right here is not my shilling. I have no idea who's shilling my courses for me, but it does warm my heart that someone enjoyed my course, found a flyer, and posted it up here. That was just a pleasant surprise for me. Anyway, so this is the thing you should know, not related to game engine architecture or the course, but a life lesson. Please indulge my tangent. Marketing is a passive buff. It is effort-based, okay? You want to make sure your portfolio is looking good. You want to make sure it's easy and possible for people to search your name and find your portfolio, which means you should make sure your name is in your portfolio website. You got SEO stuff going on. You should be going to events if you can. Many of them have a show and tell hour, and you should be showing off the stuff that you make, okay? If you do something cool or hard, do a dev blog post about it. A few years ago, I started doing some very small devlog posts on Lua for obvious reasons, right? Suddenly, I started to get emails about a year later. I started getting emails from people like at different universities and companies asking me to help them with Lua. And I'm like, I'm not an expert in this. Why are you contacting me? Well, it turns out the articles I had written a year ago blew up, and I didn't even know. And now when you search certain Lua plus certain other terms like Lua plus Unity, I'm number one somehow, okay? I'm not sure if that's still the case. And they're not even that great of articles, so I'm kind of embarrassed. I think it's like Unity Lua integration, and my articles on arborinteractive.com might come up. Anyway, that started getting me some business for Arbor Interactive. It's crazy. Anyway, you can't just do great things. All of you are great people and you do awesome things. That's not enough. I hate to say it, okay? I'm an engineer at heart. I hate to say it, but image matters. And you have to not only do great things, you have to make sure people know about this. You have to figure out how to get yourself out there and make sure people know about the great things you're doing, okay? Because the person who's going to get the promotion over you, the person who's going to get the job over you is not going to be the most competent person, probably. It's going to be the person who is pretty competent, but is great at making sure people know about what they're doing, okay? And this is the kind of thing you can build up over time, all right? Anyway, just putting that out there, there's a reason I make these course websites as cool and as weird and funky as possible. This is a big deal. This is my life's work, okay? And if I ever want to go work at another university, or if, I want to go get hired to run the MIT Media Lab in 10 years, a prestigious position, I got to have this. I got to have this, and people got to find it, okay? All right, anyway, so that's just a little bit of a life lesson for you. Not shilling, hopefully. Anyway, okay. By the way, like the most successful, wildly successful people I know, you know what's their superpower is? They have no shame, okay? They're good people, and they don't spam you too hard, but they're also not afraid to, like, I made something cool and shove that thing in your face a few times, okay? And you're like, okay, go away now. And then they go away. They're just not afraid, okay? They're the kind of people who will cold call Sid Meier himself like it's nothing. They just don't even care. They don't even care, man. I'm terrified to do that kind of thing. I'm trying to become a little bit more shameless, all right? Because no joke, it is a superpower. No shame. You need a little bit of shame, but not too much, okay? Definitely not too much. That's my advice to you. By the way, while you're a student, you might not be a student for much longer. There's literally nothing a student can do wrong that can't just be chalked up to them being a dumb student, okay? And this is what I mean. You can reach out to any company in the world. You can ask any dumb question you want to any famous person you want. If you tell them that you're a cute little student, okay, adorable, naive to the ways of the world, they'll probably respond to you, okay? And you asked a dumb question, but they're going to answer it anyway because you're a student, and it's adorable, all right? This will not be true forever. Soon, you will have graduated. You'll be in the workforce. Your advantage, okay, that you might not even realize you have, your advantage, it's ticking, okay? The clock's ticking. It's going away soon, all right? That massive buff you have is not forever. Okay. All right, anyway, here we go. We have this program. It has a table that we're kind of treating as an array. This is deeply suspicious, okay, about what this is going to be about. So we are iterating here from 0 to classes you should take. Here we go. That pound right here is a way to basically get the length, and I figured you might not know that, and I might not have covered it, so here's like a little comment telling you this is the length operator. And so we're going to iterate I from 0 to the length of this thing. And we're going to check the modulo operator. And basically, if the index I is even, we're going to print this thing, okay? So the question is, what does I start at? And if you say 0, then this is going to check out as true, and you might accidentally print EECS 298. Bad. Don't do that, all right? So what's going to happen is that I is going to start at 1, which causes this to fail. EECS 298 is at index 1 by default in this table. When we move to index 2, this will succeed and we'll print EECS 440. Check that box. Oh, by the way, this is going to be, we're starting I at 0. We are forcing our I index to start at 0. But when we index into the table at index 0, there's nothing there because the first item is going to start indexing at 1. So the first thing we're going to print is nil, actually. Second thing we're actually going to print is 440, and we're just going to leapfrog them all. So 494, Pat 305, and Education 333, and that's it, okay? Kind of a tough one. But you have an interpreter in Lua you're allowed to use. I wonder if any of you literally just programmed this yourself with the time you had in front of you. Maybe some of you didn't do it, but really I just don't want you talking to or looking at the answers of other people. This is going to cost you time to print, type this out and verify what happens. On quizzes, you can do that kind of thing, Some of you asked me whether you should use AI. I don't think I can stop you. I don't think it's a good idea for you to rely on this, okay? Maybe check your answers. I can't stop you during a quiz. I can definitely stop you on the exam, okay? I just care if you have the knowledge in your head at the end of the day. So that's all I have to say about that. Any questions about any of these comments? Okay. They're kind of fun to come up with, all right? And literally how I come up with these is I'm looking through my notes. Okay, what's interesting about Lua? What did we teach them? What do we, want them to understand and remember? Okay, I want them to understand and remember this thing, this foot gun, which is going to get them. If they don't understand it and remember it, it's going to get them bad. How do I create a question about this foot gun, right? And that's how I design all of my questions. On the exam even. Yes?
This is kind of a dumb question. Are the quizzes open note?
Yes. What? You didn't know that? Yeah, everyone is looking through all the lectures, the previous lectures, and yes, they've been open note, they've been open book. So hopefully you haven't been restricting yourself too badly, but if you have been, hopefully your knowledge is ready. Because on the exam, you will not be open note, you won't have any notes you bring in, you won't have any books you can watch. If you got some AI glasses, I'm going to find them. You're going to take the exam blind. We're going to make you look close or look far away. Okay? Don't worry about that too much. All right? I don't think any of you have AI glasses. If you do have AI glasses, we should talk. Okay? By the way, if you can't make the exam for some reason, that is bad news because there's not going to be a makeup. Okay? Probably. If you can't take the exam for some reason, it better be a horrific reason, okay? And you need to contact me ASAP. There will be no mercy, and there will not be much gentleness when it comes to getting your exam extended or getting a makeup produced. The exam is on, let me see here. The exam is on the 3rd, okay, is on a Friday from 5 to 9 p.m. Some of you have extended time, and if the 4 hours don't cover that, because remember, the exam itself is actually 2.5 hours, but we just kind of give everyone extended time to 4, then, you should talk to me and we'll get something figured out. Usually we put you in the Wolverine Soft office so you can get a few extra hours, and then we move you into the main exam room so you can spend the rest of the hours with everyone else. Yeah, if you have some things that are going to complicate your exam, then contact us immediately. You should have done so earlier. Otherwise, hold your peace because there will be no mercy or gentleness when it comes to moving the exam backward, because that creates huge security and equity questions, okay? Anyway, it's not going to be that hard of an exam, okay? You want to take it. It's going to be really nice. You're going to get a big bundle of points. Your grade's going to go through the roof, probably, for almost all of you. All right. There's a reason the average is an A- on this exam. It's not that nasty of an exam. Okay, sweet. So what I want to do is I want to talk about Box 2D. This is a legendary engine. I'm going to prove it to you in just a second. This is the technology that within one short week is going to take your engine from something that is expressive and powerful, right, but also very stiff, okay? If you want deluxe realistic physics, you got to write that yourself, and good luck doing that in 1 week. We are going to use Box 2D to bring our 2D worlds to life and really start to make things that are feeling kind of realistic, all right? So let's talk a little bit about Box 2D. You need to implement it, so we're going to go over some caveats here. Box 2D, it was created by a very prominent developer named Aaron Caddo in 2006. I believe he's at Blizzard now. He created Box 2D actually as an educational tool for Game Developers Conference in 2006. I think there was like a physics engine workshop, and he designed Box 2D to teach people how to make their own physics engine. Kind of like how I designed and created the A2 engine to teach y'all how to make your own engine, okay? Just like that. He's much more famous than I am, though. So he open sourced the physics engine, improved it, and open sourced it a year later, and he gave it the wonderful, very pleasant MIT license, a license that raises very few questions, no matter what you want to do with it. He used platform-independent and standard C++, which means it's very portable, and there actually ended up being a lot of different ports of Box 2D as a result. There's a JavaScript port of Box 2D. There was an ActionScript, like Flash, port of Box 2D back in the day. There's a Java port, a C# port, there are all sorts of ports. If you want to make a 2D physics-rich game, there's going to be a port for your language and ecosystem of Box 2D. Probably. Really cool. It has two different modes. It has a fixed point and a floating point mode. Floating point tends to be much faster, but fixed point basically is doing calculations using mainly integers, and that lends your physics engine a lot more determinism. In case you need a game, in case your game needs a replay system, or if you want to have consistent online multiplayer in which you just send the inputs across the wire and the physics simulation plays out the same way on both machines, that's going to be really useful to you. Okay, that more deterministic, a bit easier to work with fixed point mode, that tends to be slower. Okay, fixed point hardware I think is usually not as fast as floating point hardware on the processors. I don't know a whole lot about that, though. It has widespread usage in game engines, okay? Unity uses it. If you ever use, how many of you are like Unity people? You've used Unity before. You're familiar with it? Lots of us. This is a Unity campus, okay? We got a little bit of Unreal Engine. Soon we're going to have a little bit of Godot, but it's mainly a Unity campus. That's what Wolverine Soft Studio uses as well. The rigid body 2D system, the 2D physics system, the 2D colliders, the 2D rigid body component, all use Box 2D under the hood, whereas I believe the 3D rigid body and 3D physics systems, the 3D colliders, the sphere collider, use NVIDIA's PhysX physics engine instead. That's also open source, and if you wanted to, you could try and add that 3D physics system to your engine in that final 2 weeks as part of your research feature. It's hard to do. You probably would also need to add OpenGL for 3D rendering. Otherwise, there's not much point to having 2D rendering but with 3D physics. That'd be kind of weird, okay? Anyway, GameMaker Studio also uses Box 2D under the hood. Love 2D is an engine that supports Box 2D physics as well, built in, okay? Pretty cool stuff. Even SpriteKit, which is kind of sort of Apple's engine for their mobile app development, uses Box 2D under the hood. So pretty cool. That's what I call an industry standard. So very, very pragmatic and useful. Definitely a keyword you should put on your resume, just in case. Okay, people are going to see Box 2D and go, "Ooh, this guy's hardcore." Okay, this person is hardcore. All right. So the high-level Box 2D model, how you think about Box 2D and how you use Box 2D, we're not really going to talk about how Box 2D is implemented because I'm not that great at physics, and I don't know, okay? I'd have to create a whole new course if we're going to make our own version of Box 2D, our own physics engine. But you can learn more about this kind of stuff online. if you take this simulation right here and you freeze frame it, right like that, freeze, record scratch, okay? You're probably wondering how I got to this point. Well, here's how I got to this point, okay? Right here, this entire simulation, the whole thing, and everything you see, this is referred to as a B2 world. And the B2 just stands for box 2D. It's one of those prefix things that a lot of libraries puts on all of their data structures and a lot of their functions to prevent collisions with other libraries that you might be using in your program, okay? And you can see how we created our B2 world up here. And when you see these two lines of code, it should be a breath of fresh air. What am I referring to? I'm referring to the style of this library. Is it a classic style, crusty, hard to use C library? No. Why? Because you see a constructor. Look at that. New B2 world, and you pass in a parameter to a constructor for a class. That means you have classes. That means this is not a C library. What kind of library is it?
C++.
Yes, this is a modern, object-oriented C++ library. What, took us long enough to find one, right? Good stuff, okay? That means it might feel a bit more modern, a bit more natural to you based on the programming you might have done in Unity C#, or in your other courses like EECS 280 or EECS 281, okay? So this box 2D world, by the way, this box 2D world, its main constructor just wants a parameter of gravity. You just want to tell it what is the gravity like in this world. So we give it a B2 vec2, a vector 2. You already know from GLM, vec2, that this is just a two-tuple of floats, x and y. And we give it a 0, 9.8 gravity, okay? Why isn't it negative 9.8? Well, okay, we'll talk about that in a bit. Okay, we can then create the physics world, and we have our little pointer to a physics world that's been placed on the heap. Pretty standard so far. This world needs to have things in it. And if you have a body, some actor that is simulating, you probably have one B2 body to represent it, okay? B2 body. Here we have 4 B2 bodies. Now I want you to notice 3 of these B2 bodies are actually running around and like flying around and simulating. There's a 3rd that is colliding with other bodies, but it's not falling. It's not getting pushed around, okay? So we have 4 different bodies here, but 2 different types of bodies, okay? One is dynamic and the other type is kinematic, okay? Or maybe it's static, I don't remember. Okay, are these bodies the same? The answer is no. All right, look at them. Some of these bodies, or at least one of them, is static. You might also say this could be kinematic. All right, the others are definitely dynamic. These bodies also have, different positions. They have the same gravity, though. Okay, here is how you create a body, and we created 4 of them in this test case. And so we want to, look at how we did that. Here's how you do it. In order to create a B2 body, which is a simulating actor, we first create what's called a def. A def, all right? This, you can kind of think of it as a template, okay? We're going to create to this B2 body def, a B2 body template. And we're going to fill it out with a bunch of information and then use that template down here to actually create the body. We can set a bunch of different variables and data pieces on this B2 body def, and it'll get transferred and affect how the body works. Now first, we can check what kind of body type we want. And we can actually then do body def, which is the variable name, dot type. And we can select B2 dynamic body, B2 kinematic body, B2 static body, okay? A quick thing to note, you see this physics : create body function that takes a reference to the body definition? See this? I made that. Okay, that's mine. I shouldn't have left this in here because now this line of code is custom to my engine. But actually, it's really, this function is very simple. I think there's a create body function on the physics world that you use to create that body, okay? And that tells that particular world to create a body within that world. Because you can have multiple worlds simulating at the same time, all with their own bodies, okay? All right, let's keep going, okay? You can think of this as configuration or a template for a body that I'm going to create. Down here, we can use that body definition to create many different bodies, okay? So it's kind of like a template or a prefab or something like that, or a blueprint. In here, you can see that there are 3 major body types, and you definitely want to, memorize these, okay? Dynamic bodies, like it sounds, they are capable of moving. They can have velocity, they can have gravity, you can throw them if you want to, okay? This is the most common type of body. Kinematic is a body that can collide with things, but it doesn't have velocity, it isn't affected by gravity, and it can't be pushed around, okay? Kinematic bodies, you only move, they can move, but you have to move them by setting their position directly. The physics system, in other words, doesn't simulate them and make them move on their own. You have to use your own code to move them or warp them, teleport them around. Static bodies never move once they are placed, okay? This is probably a static body because I know I never want to move this thing. And what's really nice about those is that they tend to be more efficient. Static bodies, you know they're going to be there. They're not moving. You don't have to worry about them ever moving. And that allows you to do some optimizations with those static bodies, okay? Down here, right, you might say, well, what about configuration for other things, okay? Well, we got some other things. We've got gravity scale. So you can turn off the gravity completely or accentuate it for certain bodies versus others. You can also change the position of that body by changing the body def. You can change how high quality that body is going to simulate. It's actually called dot bullet. You can think of this as like a precision for the quality of the physics simulation. Any of you who know what like bulleting refers to? Bulleting refers to the fact that most computer simulations are not continuous. They are discrete steps, because computers are discrete systems. They don't run all the time. They run at like finite little snapshots in time. Well, I want you to imagine that I have a wall. I have a body that represents a wall, and I've got a bullet. Here's my bullet, okay? Do you see my bullet? And my bullet is moving very slowly. So it's moving slowly. Boom, on this frame, it hits the wall, and it gets pushed out of the wall by the physics system. It's good, it worked, it hit the wall. Now imagine that my bullet is moving super, super fast. It's a bullet, it's been shot, ready? Boom, in one frame, it jumped that much. The next frame, it jumps almost to the wall. On the next frame, it jumps over the wall. And because computers are a discrete system, it doesn't even know that it passed right through the wall. That's referred to as the bulleting problem. It's a difficult problem. The way that physics systems solve it is that they enable a high-quality simulation mode in which the bullet will simulate to here, but then the physics system is going to run a little check to make sure, but can it move from the previous position to the last one? Does it bump anything on the way? At which point the physics system will, boom, realize, wait a second, I can't go over there. I ran into the wall, and it will resolve it backward, and it will end here, even if it's going super fast, okay? It's more expensive, but it's higher quality physics, okay? For some objects, you turn it on. For fast objects, you probably want it on, unless you want it to go through some walls randomly. But that's what bulleting means, okay? So that's what you're setting up here for the body. There's angular damping, there's friction, all sorts of stuff, okay? But what about like bounciness, all right? Look at this test case right here. You know what was really fun making this homework years ago in 2024? Because I got to like set up all these fun little test cases and watch the boxes bounce around. It was way more fun than creating many of the other test cases for the other homeworks. Anyway, right here we have something called a B2 fixture. And in particular, we want to create a fixture, so we instead fill out a def for it. B2 fixture def. A configuration for a B2 fixture. Okay, if a body is kind of analogous to a rigid body from Unity, can any of our Unity developers tell us what they think a fixture might be analogous to? In Unity, it's about rigid bodies and one other component type. In Box2D, it's about bodies and fixtures. Yes?
Colliders.
Colliders. It's not quite a one-for-one match, but you can kind of think of fixtures as colliders, which you already got a little bit of experience with in this course, with colliders and triggers in homework 5 and homework 6. Okay, so you can create a B2 fixture def, and that fixture is going to have more information you can associate with the body. It can have a density, so mass, okay? How heavy is this thing? How hard is it going to be to push? It can have friction. It can have restitution, which is kind of a fancy way of saying bounciness, all right? Our engine uses the term bounciness because, we assume our game designers aren't going to be physics nerds, okay? As most game designers are not physics nerds, it turns out. We can use the body to create a fixture by using this fixture definition. And so it's all kind of all the way down. It's kind of recursive. The world can create bodies, the bodies can create fixtures, and the body can create multiple fixtures on itself. It can have multiple colliders, okay? A separate fixture def allows us to define things like density and friction and restitution. What about shape? This is the really big one. In Unity, a collider is mostly about helping you define the physics shape of an object. An object might look like a human and be rendered with all this detail. Look at all those polygons. It's rendered in high detail, but its physics is often much simpler. Like I could be a box collider, or I could be a capsule collider, or even a sphere collider. And that happens because computing physics collisions is more expensive than computing rendering. Okay? It kind of depends, and so you want your physics to be rendered in high detail. Sorry, you want your characters to be rendered in high detail, but you want their physics to be computed in low detail. Okay, anyway, all right. We really want some shapes besides just the default boxes, because, for instance, you might want to have a circle. A lot of characters running around are implemented as rolling circles, okay? That can be quite fun. So, in this particular homework, your engine will need to support two different shapes. Boxes, i.e. rectangles of different widths and heights, and circles. So you can see here that there's also a data type called a B2 polygon shape. And if we want this to be a box, we can use that variable. It has a function on it. Isn't like object-oriented programming nice? The code completion is going to be really great on this project. It's going to be super easy to learn. We have a set as box function where we give it the width, we give it the height, and there you go, okay? We can then grab a fixture definition, like what we did up there, and we can set density and friction and restitution all like that. But look at this, there's also a dot shape property that we can use to hook up that shape we made, that box we made, to be the shape for our fixture, which becomes the main shape for our body, okay? In this homework, we never require you to have more than one fixture for a body. So you don't really have to worry too much. You can think of it as your collider, and you're only going to have one of them for any of your actors, okay? There you go, right there. Sweet. Fixtures also store shape for the body, kind of like a collider and trigger. You know what? I lied, okay? Your body might have a collider, it might have a trigger, or it might have both, or it might have neither. So you might have two fixtures on any given body, whether there's a trigger and a collider defined on that body, that actor, okay? Okay, you can also look at this. If I don't want a box, I can create a circle collider. By creating a B2 circle shape, that variable is going to have an M radius value on it. And then in my fixture def, I can specify the circle shape instead of the box shape. And now I've got my beautiful rolling circle. All right, and it's going to be really, really cool. All right. So here's a way to think about the entire Box 2D data structure set all the way down. And you're going to see it's pretty recursive. We have a Box 2D world, a B2 world. This is a container for everything in any given physics simulation. This Box 2D world has to be time-stepped manually, i.e., your game loop has to call the physics world step function. All right, if you don't call this, nothing is going to move forward. The physics won't simulate and nothing's going to happen. These variables right up here are variables I give to you, so you don't have to worry about them too much. But we're telling the physics engine, how much time do you want to pass in this physics world? And then these two things are setting the quality standards, more ways to set quality standards for the precision and accuracy of the simulation. These are pretty good numbers. These create a good simulation without being too expensive, okay? Okay, the world, your B2 world, might have multiple bodies within it, as we've seen in several of our examples. These B2 bodies are basically your actor, or they kind of represent your rigid body component on your actor. They basically are your actor, okay? If your actor has a rigid body, then it also is going to be a B2 body, okay? The rigid body is a B2 body. Okay, those rigid bodies, okay, those B2 bodies might have 1, 0, or multiple fixtures, depending on, does it have a collider? Does the body have a collider? Does the body have a trigger? Does it have both? Does it have neither? One really interesting thing is if you have a collider, that means you have a B2 fixture, which means you have additional mass. That's going to affect how you simulate. If you have both a collider and a trigger, you're going to have even more mass. So that's going to kind of make you a bit harder to throw. And that is something that is a source of bugs and confusion on the homework. The assignment spec explains this. I think hopefully it does it pretty well. If you look at this code up here, right, you can see that a body can have multiple fixtures. If you look at this fixture definition, one of the properties it has, this data type has, is the is sensor Boolean. And as you might suspect, sensor is what Box2D calls a trigger, okay? If you have a dot sensor, you're going to have to change which lifecycle functions you call when you touch something. You're going to have to, it's going to change whether you pass through something or whether you slam into it, okay? In Unity, we also have what's called a layering system. The layering system isn't something we're going to give the user access to, but we can use these two categories. You'll read about them more during the homework. But .filter, .category bits, and .filter, .mask bits, you can plug values into these fields to control which objects are allowed to hit which other objects. In this particular homework, the rules are very simple. We made them simple. We didn't really expose them to users. That's just to save you some time on the homework. Basically, I think triggers can only hit other triggers and colliders can only hit other colliders. You really want to set this up properly, and the homework will help you do this so that you don't get bugs where a collider accidentally hit a trigger, something that should be a trigger, okay? There are other miscellaneous physical properties. We already showed you those. This one's kind of cool right here. The fixtures provide a variable called .userdata. And that .userdata object has a variable, a member called pointer. And you could store anything in this pointer, anything. It's meant for you to add tracking data to the fixture so that when things collide with each other, you can figure out, like, what does this fixture belong to? What is this fixture? Which game object is it associated with? Which actor is it with? And that's why you see me putting the actor pointer into the dot pointer variable. Now, what is reinterpret cast? So pointers, as far as I know, pointers are the same size, okay? This cast right here is telling the compiler to stop freaking out that I am trying to jam an actor pointer into a uint pointer type, okay? Compiler freaks out. We say, hey, it's fine, it's okay, stop freaking out. We know this is an actor pointer. We're going to get it out and treat it like an actor pointer. It's fine, okay? All right, any questions? Okay. We then, right, we have fixtures, but those fixtures don't necessarily have a shape. And so our fixtures are going to have a shape. Maybe it's like a circle, maybe it's a box, which in our case is a B2 polygon shape, B2 circle shape. We have a couple different options, not too many. What you're basically doing in this homework is you're recreating a lot of the features that you see in the Unity game engine. As far as physics goes, rigid bodies and colliders, we made it as simple and easy as possible for you though. In this homework, the rigid body component and the collider component are one and the same. They are all inside of a single rigid body component. There are no colliders. Maybe you can separate them if you want to on your own time after the course is done, okay? So, one really big thing with physics engines is detecting collisions. You know, you can simulate a fun little physics experiment, but if you want to make a game, then eventually you're going to want something like this. You're going to want to make a game mechanic in which you touch something and something happens. When I touch this yellow ball, I launch my player character into the air. What I'm actually doing is I'm grabbing the rigid body, and I'm setting the velocity on my rigid body to send it flying through the air. It's pretty cool. And in most game engines, you know how most game engines give you a start, an update, and a destroy lifecycle function? They call it different things. Of course they do. Unreal Engine calls it event begin play, event tick. And I forget what the destruction one is. Maybe event cleanup. In Unity, it's start, update, and on destroy. In our game engine, it is on start, on update, on destroy. Well, these are additional lifecycle functions, on collision enter, okay? The idea here is that we want to give our game designers a chance to respond to collisions happening with their own Lua code, okay? For instance, a game designer might want to detect that the player has touched these yellow blocks, grab the player's rigid body component, and launch us into the air so we got a nice springy jump game mechanic. Okay, pretty cool. I want you to look at this particular box. This is an actor that is an instance of a prefab. This name is called Bouncy Box. It is a template. I used the Unity terminology prefab. I should have said template. The type is sprite render, right? It's got a sprite render in here, right? We can see it, so no surprise. It's got a rigid body in here. That's pretty cool. It's a kinematic rigid body, so we can move it around, but it's not going to simulate. It does not have a trigger. It does not have a trigger. It does have a collider, okay, by default. The component is going to have, the third component is the bouncy box component. So if you look at the bouncy box component, you can see that it has a function called onCollisionEnter. By default, all onCollisionEnter functions are expected to take in a collision object. The function will be executed when a collision occurs on that actor, but we want more information, usually, about the nature of that collision. Who else is involved? How fast were we moving? Where did the collision occur? And so this collision object is going to be passed into the Lua code by the C++ that we write in order to help our game designer have more information in which to process that collision and do something with it. So you can see here, we go if collision.other. .other is a variable that helps us get a reference to the other actor that was involved in our collision. Because it's an actor, we can check its name. If the name of the actor we touched is the player actor, then we're going to grab the rigid body of the actor, the player. We're going to get the current velocity of the player, and we're going to set a new value, a new vector 2 for the player that has minus 15. So we're going to go launching up into the air. We got this new vector 2 in a variable, and we set the velocity on the rigid body component. And that is what launches up into the air, okay? Launches us into the air. There's another function for on-trigger enter. A good example is when you get to the end and you go into these little checkpoint flags. That is a trigger collision. Why? Because we are detecting a collision and running code in response to it, but we are not having any sort of physical impact on the collision. That doesn't happen, okay? And so, right, we want a detection of the collision, but we don't want any physical collision to occur. Here, we have a template of type victory box. Oh, I accidentally left the name bouncy box, so that's an error on my part. It doesn't break the game, though. We have a component called victory box, and in that component, we don't have on collision enter, we have on trigger enter. And this is a function that will automatically get called by our engine if we bump into something that has a trigger on it. So, just like before, it sends in a collision object, and we can use it to get the other actor that we touched, and we can get the name of that actor. So if one of these victory boxes touches the player, then we're going to publish an event. The event is called event_victory. And as you might expect, that's going to do a bunch of things, like stop the timer and change the text that's being rendered to the screen, okay? If it were a more advanced game, we could also move on to the next level, and we could do a bunch of other stuff in response to that event being published. All right? Sound good? So, we have to make all this work. The game designers just get this for free, okay? On trigger enter, on collision enter, they're very lucky. They're lucky that we're so nice to them, okay? And so, we need a way to detect collisions in C++, because that's where we live. Now, the cool thing is that Box 2D is very good at this, and it will detect collisions for us. We simply need to move those collisions around and make sure that it's being processed properly. We're kind of forwarding the information, okay? Box 2D has kind of a funky way that it wants us to do this. You need to create a brand new class, okay? And that C++ class that you create, we usually call it like contact listener, or maybe collision listener, or something like that. It needs to derive from the Box 2D class B2 contact listener. As part of that derivation, we need to override the begin contact and end contact function. These functions are going to pass in information to us that will explain which colliders, which fixtures collided with each other, and we need to write those functions to respond to that ourselves, basically by figuring out which actors were involved and then calling the right functions on the Lua actor components, okay? All right, so this is information related to the collision. We write these functions, and Box 2D will call them automatically. Isn't that crazy? Our game designers write Lua code, and if they write it correctly, we will call them. If we are writing C++ code, and if we write them correctly, Box 2D will call them. So it's like this chain of functions calling other functions that get registered, okay? It's really pretty cool. It's Inception, right? Recursive. So what you do here is once you've designed this class and written the code you want to, and that's part of your homework, you have to figure out what code you want to write. You can then create a new instance of that class, and then you need to register that contact listener with the physics world. And there's a function for you to do exactly that, set contact listener with the object you just created of your own type, okay? Pretty cool. The B2 world is now going to be responsible for calling those two functions you've written at the correct time and passing in the correct information. And you need to decide to do what you want to do with that information, okay? Basically, look at the actors, okay? and then look and see if they have any components. They better have components if you're even considering them. They should have some on-trigger enter or on-collision enter components. And then you need to call them. I think this homework also has on-collision stay, on-trigger stay, and I think it also has on-collision exit, on-collision on-trigger exit as well. So if you know those from Unity, you're going to have to implement those too, okay? It's not too bad. This homework, one person has completed the homework already. They know who they are. And you know what they said in the feedback? It's Austin, it's easy, way easier than homework 7, okay? That's cool. Okay, some of the value of standardization can be seen here, okay? One of the pains of having diverse dependencies. So our engine, okay, and the Box 2D engine have a different notion of direction. On the x-axis, we agree. Except in your engine, which way is up?
Negative y.
It's negative y. Uh-oh. Okay, in our engine, negative y is considered up. In Box 2D, positive y is considered up. Oh, crap. Okay? And remember, the reason negative y is up for us is to be compatible with SDL. So you're saying SDL and Box 2D are not compatible with each other? What happens if you want to use both? Well, welcome to engineering, okay? You have to make that happen. And that's the only incompatibility, right? No. Rotations are also messed up. And some of the harder test cases in the homework, I think, are you fixing the rotation system, all right? We help you out. I made it a lot easier for you. The assignment spec basically gives it away. In our engine, a rotation is defined in degrees, and it is clockwise, okay? In Box 2D, it is counterclockwise, and Box 2D doesn't use degrees, it uses radians by default in its API calls. Sick. Great. Cool. Okay, this is going to be a huge source of bugs. What a pain in the butt. All right, hopefully you can just fix this once. And really, your goal here as an engine programmer is to try and keep the user experience, the game designer experience, totally nice and consistent all the way through, okay? So you have to protect them from these dumb incompatibilities. You have to do these conversions internally to protect the game designers who are operating in Lua and want to use really friendly, natural decisions, okay? And not have to deal with this. Anyone have any questions about any of this stuff? I didn't tell you how to do everything. You know why? Because that's the homework, all right? So we want you to play around and we want you to experiment. And on this homework in particular, it's really wise to experiment, okay? Okay, I'm going to try and give you a feel for what the event bus means and why it is the way it is. Often, you have a bunch of different components in your code base. You're getting used to that by now. And your code base, your components want to talk to each other. Now, how do you usually get components to talk to each other? Well, you might use the get component function to get a reference to that component. If you aren't on the same actor, first you have to do actor.find to get the actor reference. And then once you got the actor reference, you can do actor:get component, and you can get the component that way. It's a huge pain in the butt. And also, look at this. It makes your code ugly. Actually, I don't think this is too bad. Toastmanager.requestToast. We are in a file called game control, and yet we have some logic related to UI in here. This is referred to as a hard coupling. And as nice and convenient as static functions can be, like what we see here, often you don't really want this. You want something that's event-driven. If I score a point here, I want to write code that says event bus or event.publish new score event. Okay, if I write that, I can get rid of my UI code. The UI system can subscribe to that event I'm sending through and can run code. Our systems can communicate, but they don't need each other and they don't reference each other. That's the main victory, okay? So let me show you how the event system works, okay? Normally, we have these different systems that must reference each other in their code base. Literally, the name of the class is there. The UI system has player system token inside of it. And that's not good, okay? That's hard coupling. The toast system, if you look in the source code, you will find a reference typed out right there in front of your eyes to player system. This is not good. This is hard coupling. It's what I was just complaining about. Because now, if the player system is deleted from our project, the UI system is broken. It no longer compiles. The toast system is broken. It no longer compiles. Ask yourself this: why does the UI system have a hard dependency on the player system? Can't the UI system exist separately? The answer is it should be able to if you write your code well, okay? Here's how we fix the problem, okay? We are going to get rid of this dependency. Notice the references to player system are gone. They're going away. We deleted them. There's no dependency. But if there's no dependency, how does our UI system know when there's a new player? Well, we're going to use a very famous design pattern. EECS 494 explores this a lot more, but we're almost out of time, called the event bus architecture, also called PubSub, which stands for publish, subscribe. It's very simple once you know what's going on. Here's the idea. We have an event bus in the middle here, and that event bus is basically a dictionary of types of events. And that dictionary key, which is a type of an event, could be a string, could be an actual type if you're like in C# and you've got reflection, is going to get you a value, which is going to be a list of functions that are subscribing to that event type, okay? All right, what does that actually mean? The player system is going to do eventBus.publish. It's going to publish a score event object. That score event is going to go into the event bus, and let's say UI system and toast system are subscribing to that particular type of event. Well, in that case, that score event that was published by the player system up top, that score event is going to flow into the UI system and into this toast system. And these events down here, these functions, underscore scored, is going to get that event and get run and get to do its job. Now, notice here, the UI system doesn't know about player system. The toast system doesn't know about player system. The player system doesn't know about toast system or UI system. All of our different components and classes are now soft coupled. They're loosely coupled to each other. They can communicate, but they don't need each other, okay? Event-driven programming is a really, really popular thing, and I think the assignment spec is going to go through it a little bit more, but the takeaway is this. You are going to implement an event table in homework 8. And the event table is going to have a subscribe function and it's going to have a publish function. These two functions allow our systems and components to easily communicate with each other and send each other objects called events and communicate and do their jobs. A very common thing is for an enemy to take damage. And when that happens, the enemy will it will publish a damage taken event. And somewhere on the other side of the code base, far away, the UI components will subscribe to the damage taken event. And so they will get to run code. They'll get to run a callback and update the UI whenever any damage is taken throughout the project, no matter where it happens in the code base. It's very nice. It allows distant parts of your code base to communicate without knowing about each other, which can keep your code much cleaner than the code base that we might have seen in like homework 7 Lua code, okay? I really wish I had the event table when I was programming the big test case I keep showing you, test case 7C3. And because I didn't have that, my code was a lot nastier. By the way, on this homework, a reminder, you're also going to implement the onDestroy lifecycle function, okay, which is another powerful tool for cleaning up objects when they get destroyed. All right? Okay, that was really fast for PubSub, but hopefully you can review this lecture and review the slides if you want to. Also, review the code, okay? Because some of these test cases I was showing you, especially toward the end of the homework, yeah, this victory box component literally uses event table in order to publish events, in order to trigger different parts of the code base to run when we want them to, all right? Without having to reference those other parts of the code base directly. Okay, any questions or comments? All right, everyone, I'm going to be here. For the next 2 hours. I went 5 minutes over. Thank you for your patience. And I'm going to get, in about 5 minutes, I'm going to get my office hours queue set up. So watch, and if you want me to help you out, put your name under it. Otherwise, I hope you have a great weekend. Hopefully it won't be too stressful weekend. You're almost there, okay? Light at the end of the tunnel. That's both a scary thing and also a very pleasant thing. So make sure you work hard. Not too hard, but work very hard. And make sure to cut corners if you need to in order to get caught up and get as many points as you can. Be very prudent. And don't be afraid to save some test cases for later. Put them to the side. You can always come back because you've got Git, right? Make good Git messages so you know when to come back and where to come back. And yeah, I will see you next week on Monday for the introduction of your final auto-graded assignment, the data-oriented assignment, a beautiful high-performance particle system. It's not nearly as hard as it sounds, okay? Okay, I'll see you on Monday. Take care. And everyone on the Twitch stream, on the YouTube, I will see you later as well, okay? Take care, bye-bye, and good luck.